Hello everyone, this is Pamper Chew. Today I got a kit in the mail, Dutchtronix scope clock. It's one of these things that you build and hook it up to an oscilloscope and it makes a clock. So the reason why I got this device was I've seen some of these Tektronix direct view storage tubes that were actually more than just a display, but they had some sort of electronics in them to handle graphics. So here's a 611 display. I have the 603A, but you can see it's almost an identical tube. This one here, it looks like is being restored at the Vintage Tech Museum. It's right down the street from my house, and a few of my oscilloscopes actually have come from the museum. And I was really interested in the storage tube terminals they had set up. Let's see if I can find. There's one right there. They have these really neat kind of displays, how they'll load the image onto the screen sequentially at a slower scan rate. Basically, it's not scanning it; it's just drawing it like a plotter would, and it gets stored in the tube itself. I can demonstrate here. The computer would be controlling this beam, and every time it would need to clear the screen, it would send a signal to this switch to clear the screen. And so as you're using this computer, it will load text onto the screen, it load graphics onto the screen, but every time it needs to clear the screen, it will make this green flash. It's pretty cool looking. Very high resolution. Probably my all-time favorite display technology. And so I'd like to get this to do the same thing. I'm very lucky that I live just down the street from this place, and I can go down there and get some service manuals or resources if I need to. So that's what I would want to attempt to get working with this and the device. I'm not sure that it's capable of this type of output, but at least I now have somewhere to start with in designing other hardware around that controller. Anyway, here's the paperwork. Don't need it. I'll start putting it together. And here's a power supply that I just fixed. Got new capacitors in it. My soldering iron. It's pretty obvious which parts go where. They're all labeled really nicely. Alright, it's pretty much done now. Made one little boo-boo slip there, but everything else turned out really well. So this is my final product before testing. I hooked up a Z-axis, or a Z output, which is the blanking, and I've already plugged it in briefly and it lit up, so I'm going to go ahead and hook up the cables. B and C cable. Yeah, X, Y, and Z. X, Y, Z, and RGB. That'll be easy to remember. There we go. X, Y, and Z is hooked up. Okay, I'm letting my scope warm up. These are all the little controls. Reset and storage on and off. I'll let that warm up. It says in the manual to turn up the intensity all the way, put the dot off to the side, and leave it on for about 5 minutes. That way it can relieve its excess ions from the ion trap. Alright, that AVR clock V4.2 chip is a ATM EGA 328P, and I've already taken a dump of the chip with my little reader here, and I can go in and see all these options. And I've already saved a copy. Where is it? There it is. Here's the data that's stored inside that chip. Like this in here, I could probably change some of the information. This should be ready. Almost ready. Okay. Time to plug it in. Alright. Place your bets. Is it gonna work? Wow. There we go. Isn't doing anything. Maybe I need to turn it on. Maybe I need to hit the power switch. I have no idea. This blinding LED. Let me look into it. Alright, so I have it hooked up. I didn't read any of the instructions or anything, but these jumpers along the edge here, I don't know what any of them were for. I got the little green light to come on, and then just by shorting things out, those little jumpers, until something happened. These two right here need to be jumped over, and you get an image. So that's the, yeah, it's in the right direction. I still need to calibrate it, I think. Just this little pot here. But I want to see how it handles with the storage on. Oh, that's cool. What do these buttons do? Oh. Where's my screwdriver? Hi. Are you enjoying your pie? What was that? It's a big Reese's peanut butter cup. I gotta go get some tools. That's way too bright. I gotta take that out of there. Yeah, he got a full 8 years.
He still has his Bitcoin?
No, he does not have his Bitcoin.
Oh no.
Well, he gambled it all away and spent it on things from Silk Road. Back when that was still around. So that adjusts the amplitude, the volume. So I'm going to bring it to its maximum before it clips. Actually, there might be a test pattern. Let me look for that. Where's the terminal? There's the baud rate. Burn in. Where's it keep flashing P? P, P, P. Or is it sticking its tongue at me? Hard to tell. Maybe I should read the instructions. Well, I'm going to figure this out, and then I'll make something more interesting. Alright, so I got it working fine with the XY hooked up. But there is an option for a Z on this board, and I have soldered on a connector. But I think I might have gotten the connector backwards if we observe as I attach it here. Notice how everything that remains is the blanking signal, or the signal you would want blanked out. The lines in between the letters. So I think I might just have it backwards. The 2 pins here. So the terminal works now. I still have a little problem with this noise showing up. Probably just because of how bad my shielding is on this. I had to make a cable to invert the output because I must have soldered it backwards. Let's try what I've been wanting to. It's in the effect. Alright, so reset that. Cool, huh? Mm-hmm. Or are you bored?
I'm very bored.
Only a pamper chew would get so excited over this. Okay, so that was part one of this project. Since this is probably going to be a project that'll take a few weeks, few months to complete, I will just make this part one, and part 2 and 3 will eventually be made. Anyway, I need to change some things on it. I'd like to put a heat sink on this voltage regulator. I need to check these capacitors. I didn't realize it when I put them in, but these are tantalum capacitors, and the very tip that goes inside of the capacitor is made of tantalum, and you cannot solder to tantalum, you have to weld to it. Well, I had clipped the lead short enough so that it would fit nicely, and you can see here that it refuses, tantalum refuses to flow with the solder. The solder refuses to flow with the tantalum. And what I have there is a connection that is not made at all. All the tantalum, bare tantalum, is not going to work. So I'm going to just remove these and replace them with the same thing, just I won't cut off the extra wire lead. They come with a long wire that's welded attached to the tip. So hope you understood what I meant there. The other problem, this green LED needs to be removed because it's so bright that I can't see shit after turning it on, and then looking at the scope, I can't see what I'm doing. So that green LED is going to be removed. I also want to fill in the parts that didn't come with this kit, such as the USB port, USB serial controller, and a header for direct communication to the Amtel, however that's pronounced. And that's pretty much it for now. I need to adjust the X and the Y so it's a perfect circle, or maybe even put adjustments on. There's only one adjustment, and that's for X and Y together. And I'd like to be able to adjust the amplitude of X and Y separately. Also is incorrect. Did it say Z invert and Z? Maybe that, yeah, that's exactly what I did wrong. I connected to it as if it were. It's going to go up here for now. I'm going to show everyone our power bill. It's going to go up there for now, and that's the end of part one. Hope you enjoyed this video, and thanks for watching.